Good morning, everyone, and welcome to a special edition of Bite-Sized Buhl. My name's Mike. I'm an educator with the Buhl Planetarium at Carnegie Science Center, and we're going to get your weekend started with a grand tour of the planets in our solar system. We're orbiting our beautiful blue marble planet Earth, and we're going to back away and head to our friendly neighborhood star, the Sun. I'm using our Digistar software, which we use on site at the Buhl Planetarium at Carnegie Science Center. And here we are at the Sun, the great nuclear reactor at the center of our solar system. If you take a look, you can see the sunspots visible in our image here. Those sunspots could easily be the size of planet Earth. I've actually seen sunspots through a solar telescope. It's phenomenal to think that those cold, dark magnetic clumps could be the size of a planet in our solar system. And they're only colder and darker than what's around them. If you could peel those sunspots away and bring them close to Earth, they would shine 10 times brighter than the light from a full moon. But here we are at our Sun, this amazing reactor of hydrogen and helium providing all of the heat and light we need on Earth, 93 million miles away. It would take 1 million Earths to fill our star. Our solar system truly is a star and a bunch of other stuff. And we're going to explore some of that cool other stuff right now. Surrounding our Sun first is a region of rock. We have 4 rocky planets we're going to visit today. First up is the closest planet to the Sun, Mercury. You'll notice Mercury looks quite a bit like our moon. It gets extremely hot on Mercury during the day, but it actually gets very cold at night on the dark side of Mercury. There's barely any atmosphere to speak of to retain the heat on this planet. The hottest planet in our solar system is not Mercury, but it's actually our next stop, Venus. Venus is about the same size as Earth, but that's where the similarity ends. Venus is a greenhouse effect run amok. We have this thick blanket of yellow clouds that traps infrared energy from the sun. It is 900 degrees Fahrenheit day and night on the surface of Venus. And the surface underneath that thick blanket of yellow clouds is covered in volcanic activity. The tremendous heat helps the lava to spread across the surface of that planet. The clouds themselves are raining down sulfuric acid. While Venus may glow a beautiful white color as our morning or evening star, Venus, the planet, is not someplace humans could visit. Great place for Darth Vader to build a castle, probably not so great for humans. We're going to head, though, to the twin of Venus, about the same size, but obviously very different, our own beautiful blue planet Earth. And we've come in over the Atlantic Ocean. We've honed in on South America, and we're looking at relatively recent cloud cover data. This system updates our cloud cover every 24 hours with real data from NASA and NOAA satellites, so we can track storm systems and see where they're headed. I'm going to actually take us around to the west coast of the United States, and I'm going to fly live now on an Xbox controller. Kind of a manual tour of the universe here. We'll hone in on the west coast of North America. As we tour our planets today, we're going to take a look at some of the greatest spots to visit. I'm also going to adjust time slightly. You can see I can move in hour increments here and move the sun around to give us a little more light as we descend through the clouds to one of my favorite spots. We are heading to a location known as the Grand Prismatic Springs. And I picked this because it might look like we're visiting another planet. This is a spot where we see extremophiles living, life, bacteria that can thrive in even the most extreme conditions. And those myriad of different colors that you see ringing the spring are different species of bacteria. And they thrive at different temperatures as it gets slightly cooler away from the center of that deep spring. So we see green microbes here with chlorophyll, and then we see orange and yellow microbes here with xanthophyll and other chemicals that we see expressed in leaves as well. Leaves with chlorophyll, and we see their green pigments during the spring and summer. And as they change colors, they change to yellow, orange, and red in the fall. Well, here we have microbes with those same chemicals in them at a different temperature gradient here. In the center, that dark blue you see is the actual true color of water. You need a very big amount of water, like an ocean, or a deep column of water, like this spring, but molecular water reflects light in such a way that it gives off that blue hue. So that is the true color of water that we see. It's actually too hot in the center of that spring for microbes to live. But NASA looks at Grand Prismatic Spring and other extreme conditions on Earth to learn more about what kind of life can thrive in extreme conditions. And that helps informs our thoughts as to what life might be like on harsher worlds than our beautiful life-preserving biosphere. Well, we're going to head off from Earth to our very own moon. Take a look at the beautiful colorations here in gray, white, and silver on our moon. The gray areas were known as seas to ancient people. They looked up and thought these were bodies of water on the moon. Those smoother, darker gray areas are actually covered in volcanic rock. Our young moon was volcanically active, and wherever the lava spread and cooled, that's where we see those dark patches on the moon. When our moon was young, it was also bombarded by many space rocks that covered our moon in craters. And we're going to take a look at probably my favorite crater, Tycho crater. We're going to zoom in on it right now. A space rock crashed into Tycho crater and changed the surface of the moon in minutes. It formed this mountain that you see, which is 9 miles wide. It's known as Tycho Peak. We'll go ahead and fly in for a closer look. A lot of the material upon impact shot outward, spread out across the face of the moon. But then there was a backflow. That material rushed back to the center. It had nowhere to go but up, and it formed that massive mountain monument in just a matter of minutes. As I pull away, you can see the Tycho crater is the brighter spot in your center of view. And you can see where that space rock material shot out and streaked the surface of the moon, kind of like spokes on a wheel. The next time the moon is full or almost full, look in the lower left corner from your perspective. It might look a little bit brighter. You're actually looking at Tycho crater. Well, the moon is our test bed, our nearby practice pad for testing technologies that will one day take us to our next stop here, the planet Mars. And like the moon, we have darker patches on Mars that are the result of ancient volcanic flows. Mars has a characteristic ruddy red color due to iron oxide, sort of a powdery, dusty coating over the surface of Mars. And we'll take you to my favorite feature now. We're in darkness right now, so I'm going to move the sun for a closer look at one of my favorite spots on the planet Mars. You can actually spot Mars for yourself in the morning sky, just before sunrise, just before dawn. Look up, see if you can spot a slightly orangish glow in the sky and a bright white light. That white light you'll see is our morning star Venus, reflecting light from the sun. And nearby you'll see the orange glow of light reflecting off the planet Mars. All right, as we orbit Mars here, I'm going to move the sun again. And we'll hone in on one of my favorite spots. There we go. Okay. Mars has the grandest canyon in the entire solar system. It's known as Valles Marineris, and it's the big streak you see across the front of Mars right now. On Earth, this canyon would stretch from coast to coast across the United States. It is that big. At its greatest depth, it is 5 miles deep compared to our Grand Canyon, which is 1 mile deep. And this formed as the young planet Mars was cooling and contracting. The crust cracked here and formed Valles Marineris, or Mariner Valley. Future colonists who live here would need spaceships that could endure the immense wind speeds, the choppy atmosphere here. But if they could land and build a colony and harness the wind power, perhaps they could thrive on Mars. On the left in your field of view, you'll see some tributaries, evidence of rivers that ran dry millions of years ago, but left their mark on the Martian landscape. And here are those tributaries. All of the data you're looking at is real. It's come to us from Mars orbiting spacecraft. All of the contours you see here on the cliff sides. If you were in Valles Marineris standing at the bottom, you wouldn't perceive that you were in a canyon because it is so wide and so vast. And its immense scale is even more impressive because Mars is just about half the size of Earth. In the center of your view is Olympus Mons, the largest planetary mountain in the solar system. The base of that mountain, if you trace it with your finger, would nearly cover the entire nation of France on Earth. This is an extinct volcano that blends into the curvature of the planet. It's built up on a hot spot over millions of years. Mars does have 2 moons to Earth's 1, but very different from our moon. We believe they're captured asteroids. Mars was the Roman god of war, and these moons were named for fear and panic. Phobos, or fear, and Deimos, panic. This is the moon Phobos. Looks something like a baked potato. And you can see the stress marks here as the gravitational pull from Mars is slowly stressing Phobos out, and will eventually, over a long time, break that moon apart. Well, beyond Mars is an asteroid belt where we think Phobos likely came from, and then we enter into the second great zone of the solar system. Our solar system is centered by a star, a ring of rocky planets, as we just explored, and then the gas giants. And so we've arrived at the largest planet in our solar system, the planet Jupiter. You may be able to see some fast-moving rocks on your screen. We've come straight into Jupiter's rings. Jupiter does have rings. They might not be as impressive as Saturn's, but they are there. Jupiter's more well known for those beautiful stripes, various ammonia compounds. Here at Jupiter's south pole, we can see some swirling green storm activity. This data came to us from the Juno spacecraft. Now, if you're excited in getting involved and helping NASA out, you can check out NASA's Juno mission. Just Google that online. There's a citizen science camera aboard the Juno spacecraft orbiting Jupiter. You can take your own photos of Jupiter with a camera and a telescope, send them in, and NASA might pick your photo and tell Juno what to look at next. So it's your chance to be a citizen scientist. Jupiter is almost a miniature solar system in its own right. It has so many moons. This is my favorite. It's near to the planet. This is the moon of Io. It's one of 4 moons that Galileo himself discovered on a cold January evening in 1610. So get out there with a telescope, look up, see what you might be able to find this January. Io looks a little bit like a cheese pizza. And that swish of tomato sauce you see is actually material that was ejected from a central volcanic vent. The dark spot you see in the center of that orange ring is known as Pele, named for the Hawaiian volcano goddess. It ejected sulfur compounds. That ring is about 350 miles away, circling that volcanic vent. There are hundreds of volcanoes on the surface of Io, and it's no wonder it's so volcanically active, so seismically active. Io is being pulled and stressed constantly by the tremendous gravity of Jupiter. Jupiter is so big that all the other planets in the solar system would fit inside. So you can just imagine the gravitational pull it has on its moon of Io. All right, next up is Saturn. Now we came in edge on. Saturn's rings may have disappeared in your view. In some spots, Saturn's rings are a couple miles high, but on average, they're only about 30 feet thick. 30 feet, that's it. We're pretty lucky this year, though, with a telescope, you can see the north face of Saturn's rings. They look like a beautiful golden phonograph record to me, but they're actually made of billions of particles of rock, ice, and dust. We're going to zoom into one of the gaps of the rings and take a look at one of Saturn's moons. This is the moon of Pan. It's a little shepherd moon. It shepherds the material around it. So it's moving around in these rocky, icy rings, but you can see it's forming a little HOV lane. It's just big enough to clear everything else out of its way. Zoom in one more time to Saturn's beautiful rings. Much of what we learned about Saturn has come to us most recently from the Cassini spacecraft, which did a series of daredevil dives between the planet and its rings as the grand finale to its mission. Okay, one more awesome thing about Saturn before we head off. As we speed away, take a look in your screen. You'll see a green hexagon at Saturn's north pole. That storm system is being pinched and pulled by other storms around it, and so it is six-sided. It's shaped like a hexagon. And one more moon of Saturn that we're going to check out in our grand tour today. Out on the edge of the ring system. This is an icy ocean moon. Beneath this very reflective white icy surface is a global ocean. Now, wherever the ice is thinner, it's a little bit bluer, and it actually ejects this cold slurry of material out into space. Cryovolcanoes and ice geysers blasting out not just water ice, but compounds of methane and ammonia. And this material that shoots out of these cryovolcanoes on Enceladus, this moon, actually helped to build up one of Saturn's outer rings over time. Now, because there's a global ocean underneath that icy crust, Enceladus is a leading candidate when we think about other places in the solar system where we might find life. Could there be anything in that ocean underneath the ice? That's the mystery. All right, we just passed through the ring system of the planet Uranus. Uranus was the first planet to be discovered with a telescope. It wasn't known to the ancients. It was discovered by William Herschel back in the late 1700s, around the time of the American Revolution. He actually wanted to name it after King George III of Britain, but it was named Uranus, sticking with the Roman naming conventions. The scientists have actually recreated the clouds of Uranus in a lab. And under those conditions, they've actually found that diamonds can form. So right now on the planet Uranus, it could quite literally be raining diamonds. Uranus was the first planet to be discovered with a telescope, and then scientists realized that something else just as big would be acting on it. It was predicted by math, and then it was found in space. That's the planet Neptune. That's how powerful math is. It can help you find planets. Neptune is a twin to Uranus. It has its own ring system. Uranus and Neptune both have a greenish or bluish color because of plenty of methane in these gas giant compositions. Neptune also has storms that are 10 times faster than anything you'd find on Earth. Now, as I pull away from Neptune, you'll start to see its orbit. And I've pulled away now where you can see our sun in the center. We have a few spacecraft that have come into view. The green stripe there is the path of one of our Voyager space probes. The yellow is Pioneer, a spacecraft that have gone farther out past Neptune. But as I continue around, you can notice something about the orbits of our planets. They all orbit the sun in roughly the same plane. Our solar system formed from a pancake of material orbiting our young star. You can think of the planets as blueberries that formed out of that cosmic pancake, that protoplanetary batter of material in an accretion disk around our young star. And because all of the 8 major planets orbit the sun in roughly the same plane, when we look to the sky, if you go outside and face south, if you find planets in the sky, you'll see them all arcing across generally the same path in our sky. And it's the same pathway that we find the constellations of the zodiac as well. But our last stop is going to take us beyond Neptune to a third region around our star, the Kuiper Belt. Our solar system is centered by a star. It has a zone of rock, a zone of giant gas worlds, essentially great big clouds in space, and then the Kuiper Belt, a region of ice. The Kuiper Belt is full of lots of icy material, and some of these objects are big enough to be round. They make pretty good dwarf planets, junior planets. I like to think of them as the Kuiper Belt kids. We're going to visit probably everyone's favorite Kuiper Belt kid right now, and that is Pluto. Here we've come in on the heart of Pluto, which you can see in the right of your screen there, sort of the left side of the heart. This was imaged by the New Horizons spacecraft. It sped by in 2015. The heart of Pluto is basically a great big hockey rink in space, and it's surrounded by mountains. It's a hockey rink made of nitrogen ice, the same stuff that we're breathing in our atmosphere on Earth. Nitrogen is ice cold on the surface of Pluto. New Horizons didn't have time to orbit this entire world. It did speed by, so the data we have on Pluto is incomplete. But right at the very edge of the data set, I'm going to take us in and show you right where the data set ends. Maybe I'll move the sun a little bit. We saw strong evidence of cryovolcanoes. There we go. We're coming in right at the edge of the data to a mountain or a mons on Pluto known as Picard Mons. It was named for the Swiss high-altitude ballooner, Auguste Picard. Not Jean-Luc Picard of the Enterprise, although that would be cool. Perhaps an ancestor. While we're orbiting Pluto, I'd like to take you to its largest moon, Sharon. As you can see, it's pretty close. And it's so big compared to Pluto that these two worlds orbit a common center of gravity. Could almost be argued that they are binary worlds, Pluto and Sharon. I'm going to place Pluto's orbit up as well. Pluto's in the Kuiper Belt. It does not orbit in the same plane as the 8 major planets. And we can see a white line coming down, and that's the orbit of Pluto. As we come back in, you can see that it's actually sometimes closer to the sun than Neptune. And it's in a different plane. And there are other worlds just as big as Pluto, worlds like Eris. Eris is named for the Roman god of discord and debate. The discovery of Eris caused the entire kerfuffle over what we classify Pluto as. But whatever we call Pluto, it's out there. And it's just waiting to be explored even more. All right, we've done a lot of exploring for ourselves today. I'm going to take us back to Earth now, but I encourage you to get outside on the next clear night. Just after sunset, see if you can spot the planet Jupiter. It will be a bright white color following the sun, setting in the west, or early in the morning, rising in the east before sunrise. Look for the bright white glow of Venus, the morning star, and then look for the reddish Mars nearby. But I'm going to bring us back to Earth. And we'll settle in for a landing in Pittsburgh for our grand finale. I hope you enjoyed our quick tour of planets and pancakes today. And I hope you get outside on the next clear night and see if you can spot some planets for yourselves. The universe is out there just waiting to be explored. We just scratched the surface of what you can see in the night sky. So I hope you get outside, do some exploring for yourself. And then come to Buhl Planetarium at the Science Center and let us know what you discovered. So I'll pull us back over the 3 rivers and take us in for a landing at Carnegie Science Center. And there we are. You can see Carnegie Science Center, Heinz Field in view. And we have come to our landing today. My name's Mike. It's been my pleasure to take you on this bite-sized Buhl. Keep looking up, enjoy the wonders of the cosmos, and wishing you all clear skies. Have a great weekend, everybody.